In the last class, we have seen 2 marks questions. So in today's class, we will see 8 marks question for the subject geotechnical engineering. I'm sharing the screen. I hope it is visible to you. So the problem states that in its natural condition, a soil sample has a mass of 22.9 Newton and a volume of 1.15 into 10 raised to minus 3 meter cube. After being completely dried in the oven, sample weighs 20.35 Newton. Find bulk density, water content, voids ratio, degree of saturation, air content, dry density, and percentage air voids. So these things you have to cal this before solving the problem. The thumb rule is you should read it twice. So what it says, in its natural condition, a soil sample has a mass of 22.9 न्यूटन. एक नेचुरल कंडीशन में एक सॉइल सैंपल है जिसका मास है 22.9 न्यूटन और वॉल्यूम है 1.15 टू 10⁻³ मीटर क्यूब. सॉइल सैंपल है जिसका मास 22.9 न्यूटन है और वॉल्यूम है 1.15 टू 10⁻³ मीटर क्यूब. आफ्टर बीइंग कंप्लीटली ड्राई करने के बाद ओवन सैंपल में इसका वेट हो गया 20.35 न्यूटन. तो कम हो गया वेट. तो आपको क्या मालूम करना है, फाइन बल्क डेंसिटी, वाटर कंटेंट, वॉइड्स रेशियो, डिग्री ऑफ सैचुरेशन, एयर कंटेंट, ड्राई डेंसिटी एंड परसेंटेज एयर वॉइड्स. इतने सारे चीजें आपको मालूम करना है. So the given data is mass of soil in natural condition m is equal to 22.9 Newton. So 22.9 divided by Newton to convert it to kilonewton divided by 1000, it comes out to be 0.0229 kilonewton. Next, mass of dry soil mb is equal to 20.35 Newton. So again you divide by 1000, it comes out to be 0.0203 kilonewton. Volume V is equal to 1.15 into 10⁻³ meter cube. Assuming specific gravity G equal to 2.7, bulk density rho B is equal to M by B. So M is 0.0229 divided by volume is 1.15 to 10⁻³ So gamma B is equal to 19.9130 kilonewton per meter cube. And water content W is equal to M minus MD by MD. Capital M is 0.0229 minus 0.0203 divided by 0.0203. So your water content comes out to be 0.128 or 12.807%. Next, dry density gamma D is equal to gamma B by 1 plus W. Gamma D is equal to gamma B is how much? 19.9130 divided by 1 plus what you can say W is 0.128. So it comes out to be 17.6533 kilonewton per meter cube. So your voids ratio is equal to G gamma W by gamma D minus 1. Or E is equal to G is how much? 2.7 into gamma W is 9.8. Gamma D is 17.6533 minus 1. So your E comes out to be voids ratio comes out to be 0.4988. Degree of saturation SR is equal to Wg by E, or SR is equal to W 0.128 into G is 2.7 divided by E is 0.4988. So your SR comes out to be 0.6928 equal to 69.28%. Next, air content. What is the formula for air content? Air content is nothing but 1 minus S, where S is degree of saturation. 1 minus S is 0.6928. So it comes out to be 0.3072 or 30.72%. Finally, percentage air voids and beta I is equal to gamma D is equal to 1 minus beta I into G gamma W divided by 1 plus WG. Gamma D is how much? 17.6533. 1 minus beta I. G is nothing but how much? 2.7. Gamma W is 9.8. 1 plus W is 0.128. G is 2.7. So 1 minus beta is equal to 19.644 divided by 17.6533. So your beta A comes out to be 0.1127. Now briefly explain common clay minerals in soil and their structure. What we have to do, we have to briefly explain common clay minerals in soil and their structures. So clay minerals have two basic structural units, tetrahedral unit and octahedral unit. So the tetrahedral unit consists of a silicon atom at the center, surrounded by oxygen atom at the four vertices. It is represented by a trapezoid. Octahedral unit. The octahedral unit has either aluminum or magnesium at the center, with hydroxyl occupying the six vertices. It is represented by the rectangle. So clay minerals have two basic structural units. Number one, tetrahedral unit. How tetrahedral unit we are defining? The tetrahedral unit consists of silicon atom at the center, surrounded by oxygen atom at the four vertices. It is represented by a trapezoid. Similarly, octahedral unit is the octahedral unit has either aluminum or magnesium at the center with hydroxyl occupying the six vertices. It is represented by a rectangle. The common clay minerals are as follows. Kaolinite. This is the most common clay minerals of kaolin group. The structure is made up of gibbsite and silica sheets, arranged one above the other in the form of pyramid. It is formed when the ratio of silica to aluminate ratio is very low. Next type of structure is Montreborillard. This is the most common mineral present in expansive clay soils. It is 2:1 clay mineral and very active. One gibbsite sheet is sandwiched between two silica sheets. Soils containing montmorillonite clay minerals exhibits high swelling and strength characteristic. Elite. It is similar to montmorillonite, but they have potassium ions in between two structural units, but they are more stable than montmorillonite. It is 10 Armstrong thick. This is about 20% replacement of silicon by aluminum in the tetrahedral unit. Differentiate between compaction and consolidation. So, what is compaction? Expulsion of pore air. How you are defining compaction? Expulsion of pore air. Similarly, consolidation, expulsion of pore water. What we are trying to do, we are trying to understand what you mean, what is the difference between compaction and consolidation. Compaction is expulsion of pore air, whereas consolidation is expulsion of pore water. Compaction, a soil involved is partially saturated. In case of compaction, the soil involved is partially saturated, whereas in consolidation, fully saturated soil is used. In compaction, it is applies to cohesive as well as cohesionless soil. Compaction is applied to both cohesive as well as cohesionless soil, whereas consolidation it is applies only to cohesive soil. Brought about by artificial or human agency. Compaction is brought about by artificial or human agency, whereas consolidation brought about by the application of load or by natural agencies. Fifth difference is dynamic loading is commonly applied in case of compaction. In case of compaction, what is happening? We are applying dynamic loading, whereas in case of consolidation, static loading is commonly applied. In compaction, it improves the bearing power and settlement characteristics, whereas in consolidation, it improves bearing power and characteristics. Next, seventh, relatively quick process. Compaction is a relatively quick process, whereas consolidation is a slow process. Compaction is used in embankment and earth dams, whereas consolidation is used in foundation. What are the effects of compaction on the soil properties? Next question. The effect of compaction on the soil properties are number one, change in structure of soil. What is happening due to compaction? There is a change in the structure of soil. The coarse grain soil maintain a single grain structure at any possible void solution or water content, whereas clay soils are a bit complicated access with respect to their structure. So what is happening? Due to the effect of compaction, there is change in the structure of the soil. The coarse grain soil maintain a single grain structure. Coarse grain soil क्या हो रहा? Single grain structure at any possible voids ratio or water content. Whereas clay soils are a bit complicated access with respect to their structure. Next, number two, permeability. As the compacity efforts increases, the permeability of soil decreases because of the increased dry density and better orientation of particles. Second effect of compaction is permeability. As the compactive effect increases, the permeability of soil decreases because of the increased dry density and better orientation of particles. Next, shrinkage. For the same density of soil, compacted dry of optimum shrinks less than the sample compacted wet of optimum. Shrinkage. For the same density, soil compacted dry of optimum shrink less than the sample compacted wet of optimum. Last effect of compaction is swelling. Clay soils compacted dry of optimum exerts greater swelling pressure and swell to higher water content than the sample of the compacted wet of optimum. So dry of optimum, wet of optimum, we are forming a base for it. If suppose clay soils which are compacted dry of optimum, the more swelling is observed when compared to soils compacted wet of optimum. So now module 3 8 mark question explain hydraulic gradient, seepage velocity, superficial velocity, coefficient of percolation. So how you will define hydraulic gradient is the rate of change in hydraulic head water pressure per unit distance in the direction of flow. So how we are defining hydraulic gradient? It is the ratio of hydraulic head per unit length. It is the ratio of change in hydraulic head. It is the defined as ratio of change in hydraulic head, that is water pressure per unit distance in the direction of flow. That is I is equal to H by L. Next, seepage velocity. What is seepage velocity? It is defined as the rate of discharge of percolating water per unit cross-sectional area of voids perpendicular to the direction of flow. So how we are defining seepage velocity? सीपेज वेलोसिटी एक ऐसी वेलोसिटी है जिसकी तरफ से रेट ऑफ डिस्चार्ज हो रहा हो पानी और percolating water per unit cross sectional area of voids perpendicular to the direction of flow. Direction of flow is very important. Superficial velocity. It is defined as the velocity of flow or the rate of flow through the soil mass after entering in and emerging out of the total voids present in the entire mass. See here, there is a big difference between seepage velocity and superficial velocity. What is happening in case of superficial velocity? It is defined as the velocity of flow or the rate of flow through the soil mass after entering in and emerging out of the total voids present in the entire soil mass. Coefficient of percolation. What do you mean by coefficient of percolation? The rate at which water moves through a soil particle after measured in terms of volume of water passing through a unit area per unit time. is known as your coefficient of percolation, K equal to V by A into T. Next is what is flow net? Explain its characteristic. A flow net is a graphical representation of two-dimension steady state groundwater flow through एक्वीफायर्स। तो क्या है फ्लो नेट? एक ऐसा ग्राफिकल रिप्रेजेंटेशन है टू डायमेंशनल। A flow net is a graphical representation of two-dimensional steady state groundwater flow through aquifers. So the characteristics of flow nets are or streamline represent flow path of particles of water. The first characteristic of flow net is flow lines or streamlines represent flow path of particle of water. So how the flow path is visible to us? Through streamline. Flow lines and equipotation lines are orthogonal to each other. See here. What we are trying to say, flow lines and equipotential lines are orthogonal, that is perpendicular to each other. A flow line cannot intersect another flow line. What is happening? Suppose flow line is moving. One flow line cannot cross another flow line. It has to wait for it. Few flow lines are impermeable boundaries. फ्लो लाइन्स क्या है? इम्परमेबल बॉडीज हैं, मतलब अभी भी वो लोग गंदा पानी इधर उधर से लेते जा रहे हैं। An equipotent line cannot intersect another equipotent line. एक जो equipotent line है दूसरे को कनेक्ट नहीं हो सकती, इंटरसेक्ट नहीं हो सकती। The discharge in a flow channel is constant. जो डिस्चार्ज है फ्लो चैनल में क्यू वो कांस्टेंट है। Now list and discuss the factors affecting permeability of soil. So what are the factors affecting permeability of soil? Number one, grain size. ग्रेन का जो साइज है उस पर भी परमेबिलिटी डिपेंड करती है। कैसे? परमेबिलिटी वेरीज अप्रोक्सीमेटली एज द स्क्वायर ऑफ द ग्रेन साइज। सिंस soil consists of many different size grains, some specific grains has to be used for compaction. What is happening is compaction test we have to carry it out. So what we are trying to understand, what is the effect of permeability. So as you said that permeability is in big demand, and they are asking about it. How what are the our records as per permeability? So permeability varies apparently as the square of root of grain size. Since soil consists many different size grains, some specific grain size has to be used for compaction. Effect of properties of pore fluid. So what is the effect of properties of pore fluid? The coefficient of permeability has the same value for all fluid and all temperature as long as the voids ratio and the structure of this structure are not changed. See here, the coefficient of permeability value is same. It will not change. Effect of properties on full fluid. The coefficient of permeability has same value for all fluid and all temperature as long as the voids ratio and the structure of the structure remains unchanged. Number three, effect of voids ratio. So, what is the effect of voids ratio on compaction of soil? The laboratory experiments have shown that the factors of permeability changes relatively with change in voids ratio on unstratified sand samples. But however, it is very apparently for clays, saturated or structural arrangement of soil particles, entrapped air and for matter, absorbed water in clay soils. Next is explain briefly spring mass analogy. So if you see the figure, in the figure, spring is there, cylinder which is void filled with water, while opening is there for permeability of soil mass. The figure shows a spring with piston on its top, placed in a cylinder containing water up to the depth of the piston and a value E at its bottom. Water will be the Water will be free of stress since the whole load is carried by spring alone. If the pressure on the piston is increased and the valve is cooler, the spring constant deforms since water is incompressible. Hence, additional stress entirely borne by water. If sigma denotes the total pressure, U denotes the pore water pressure. Effect of voids ratio. The laboratory experiment shown that the factors of parameter changes related with change in voids ratio of one stratified sand sample, but however varies appreciably for change. Saturated or structural arrangement of the soil particles. It is also a factor affecting consolidation. Entrapped air and foreign matter. Absorbed water in clay soil. Explain briefly spring mass analogy. Say spring, it consists of grain size cylinder voids filled with water valve within the pyramid. Below figure shows a spring with piston on stock placed in a cylinder containing water up to the bottom of the piston and the valve here at its bottom. Water will be free of stress since the whole load is carried by spring alone. If the pressure on the piston is increased and the valve is closed, the spring constant deforms since water is incompressible. Hence, additional stress entirely borne by water if sigma denotes the total pressure and if sigma denotes the total pressure, U denotes the pore water pressure. Sigma is equal to sigma dash plus U. Our sigma is nothing but 12, sigma dash is 10, plus U is 2. So it comes out to be 12 units. Let the valve open slightly so that some water escapes and then valve is closed. So what we are trying to do is we are opening the valve for few seconds. Let the valve open slightly so that some water escapes and then valve is closed. Due to the escape of water, piston moves down. The spring is compressed and hence some pressure borne by water, which is pressure borne by water is now transferred to the spring. That is 2 is equal to 10 plus delta sigma dash plus 2 minus delta sigma dash. Now the valve is fully open. Water will escape at the as 2 units and the pressure entered from water to spring. 2L equal to 2L plus 0. Sigma equal to sigma dash plus U. So, what are the assumptions made in the Tazki's one-dimensional consolidation theory? So, the first assumption is the soil is homogeneous and fully saturated. What we are assuming, the soil is fully saturated. It contains ample amount of water. Apart from that, the soil is also homogeneous. Next, the soil particles and water are incompressible. The soil particles and water are incompressible. The deformation of the soil is due to the change in volume. Why the deformation of soil taking place? It is due to change in volume. Darcy's law for velocity of flow of water through the soil is perfectly valid. That is Q is proportional to I. Q is equal to Ki or Ko is equal to K into A into H by T. Darcy's laws for velocity of flow and water through the soil is perfectly. Coefficient of permeability is constant during consolidation. One more problem we solved. A Shane, a shear vein of 75 mm and 110-meter length was used to measure the shear strength of soft clay. If a torque of 600 Newton was required to shear the force, calculate the shear strength. The valve then the valve was then rotated rapidly to cause remolding of the specimen. The torque required in the remodeled state was this much determine the sensitivity of this soil. So what are the things given to you? Vein diameter is given 75 mm. You convert this into centimeter, it will be 7.5 centimeter. Vein length is 110 mm. Again, it will be 11 centimeter. Torque applied at failure is 6000 Newton meter. So your 2F is equal to 2 pi d square bracket में h by 2 plus d by 6. T is 600. Pi into d square 7.5 square. H is 11. 2 plus 7.56. So it comes out to be 0.50. 0.503 kg per centimeter square. And similarly, C equal to 2F equal to 0.403. दोनों correct. For remolded state, the shear strength will be in direct proportional to the torque. Sensitivity C in undisturbed condition. Sensitivity C in undisturbed condition to the C in disturbed condition. Similarly, sensitivity T in undisturbed condition to T in disturbed condition. S equal to 600 by 2, 3. Since resist sensitivity is between 2 to 4, the clay is normally clay with a honeycomb structure. What are the advantages and disadvantages of direct shear test over triaxial test? So the advantages of direct shear test over triaxial test is direct test is much quicker test to perform as one compared to triaxial test. What are the advantages and disadvantages of direct shear test over triaxial shear test? So first we will see advantages. Direct test is a major quicker test. The advantages of direct shear test over triaxial test are direct test is a much quicker test to perform when compared to triaxial test. Triaxial test you go slowly you can go. It performs it, it performs it can be prepared on both it direct test is a much quicker test to perform as when compared to triaxial test. Triaxial test it can be performed on both cohesionless and cohesive soil. Whereas triaxial flood systems बना रहे हैं it can be performed on both cohesionless and cohesive soil, whereas triaxial test can be conducted only on cohesive soil. The procedure is much simpler as compared to triaxial test. So these are the advantages of direct shear test over triaxial shear test. Now disadvantage. The stress conditions across the soil particles are very complex. So if you have seen that the building is subjected to zone 6, what will happen? It is most likely to undergo earthquake, as a result of which the procedure is much simpler. Procedure के मेरे को मार्क्स नहीं देते अलग से आपको. If you have correctly then only होगा. Disadvantages, stress conditions across. अब पढ़ कर नहीं आना, पढ़ कर तो एक होगा. Student. So what are the disadvantages? Stress condition across the soil sample is complex. As compared to triaxial test, there is little control on the drainage of soil. So we are left with 10 mark question that we will see in the next class. I hope you all are having a good time. If you have any doubts, queries related to today's class, you can just drop a message in the comment box. Also, you can mail me at nadim@k1.university, or even if you have more doubts, you should call me at 8553171859 after 6 p.m. daily. So module 4 in 8 mark total 11 questions are there for 8 marks, and 27 questions are there for 2 marks, and more than what you can say. How many questions? 10 mark question from 12 to almost from 12 to. Okay, this we have seen already. This also we have seen quicks and phenomena and all. Now we were left with 10 mark question that we will continue in the next class. Hope you all have a nice time ahead. Okay. So this completes our class on basic geotechnical engineering. We have studied our 2 mark question as well as 8 marks question, and we have just glance for 10 mark question also. I hope it will be fine. Okay. Thank you, Anand. Okay. So if you have any doubt, you can just place it chat box, or you can email me at nadimadar@kevin.university. So we are only left with 10 marks question that we will see in the next class.